Hi, ladies and gentlemen. Welcome to SA Accounting Academy. Here's a short clip on one of our previous webinars. I hope that you really do enjoy it.
Morning, my name is Tarryn Lyn Wright. I'm a partner at Durban, and I'm a member of the National Technical and Training Committees. I've been in the industry for quite a long time, and I serve on the Cycle Ethics Committee, and I'm also an urban proficiency interview panelist. And I do training not just for WER in South Africa and WER Durban, but WER around the world. So I'm very excited to be presenting training to people who are not part of WER as well.
So my name is Douglas Lottering. I am an IT auditor as well as a data analyst. So I've been with WER for about 16 years. I have about 10 years IT audit and data experience.
So this morning, just to take you through the outline, we're going to do a brief introduction to big data, as well as our reasons for analyzing big data, the uses of big data, how we use it in auditing, how we use it in accounting, how we use it in commerce, machine learning and robotics, some really cool stuff around that. Throughout, I'll concentrate on a particular entity and how they've used a combination of AI, big data, and machine learning. We'll also look at some disadvantages, because not everything in our world is advantageous all the time. And then we'll wrap up and conclude. Just to point out that this session is not for any data scientists out there. It really is aimed at accountants and introducing the theory behind big data and big data analytics. And we allow Doug to talk to this quote. He found a really awesome quote, and data is a precious thing and will last longer than the systems themselves.
Yeah, so for those of you that don't know who Tim Berners-Lee is, he is the creator of the World Wide Web. So this is a quote he actually put through quite a while ago. And it still holds true today. Data doesn't disappear. So you can have a system that gets replaced over and over and over again, but chances are the data that was stored on it will get moved and will just carry on being recycled. And even stuff that you post into the web is always there. There's always a trace of it somewhere.
Is this what we call a digital footprint?
Yeah.
So for people who do forensics, as an example, IT forensic auditors, how would they use that digital footprint in their cases?
They've got various tools that can go and extract data, even that's been scrubbed and cleaned and deleted, formatted. They have some ways of still finding traces of that data on hard drives, in cloud storage devices, and all that kind of stuff. So,
and the excuse of, oh, but that laptop's gone, so you'll never find it?
Yeah, it doesn't always hold true. Sometimes it does, but most of the time, because everything is interconnected, the data will find a place to sit, and the forensic guys will find it.
Awesome, thank you. So I'm not a technical expert, so when I have to look at definitions, I actually have to go research them. So we looked at what the definition of big data was. And you're going to find throughout the session, by the way, that Doug will say data, and I will say data. I'm just very South African. And dictionary.com defines big data as extremely large data sets that can be analyzed computationally to reveal patterns, trends, associations, especially related to human behavior and interactions. And then it gets further defined with increased variety, bigger volumes, and bigger velocity, higher velocity. So, in other words, it's bigger, more complicated data collections, particularly those derived from new data sources, because there are new data sources all the time, particularly if you look at your social media. They are due to the larger size of these data sets. You can't just use Excel to analyze something. You can't just necessarily even use ACL or IDEA, although they do go some way in analyzing data. You actually need something bigger to handle them. And the nice thing about those, we can now solve challenges that previously we thought were unsolvable. Now we can start solving some of those issues. So we have the 3 V's of big data. Volume, okay, large quantities, measured in petabytes and zettabytes. Don't talk to those a bit later, but I looked at that and I said, Douglas, you might as well be talking to me about dinosaurs, because, I mean, the words sound pretty much the same, they're huge. Velocity, this is the timing and source of the data, and they are diverse, they are complicated because they come from all over the show. So how do you gather it? How do you store it? And how do you analyze it? Then you've got the variety. You've got the format and the structure of the data. It's changed from a prominent database structure to a large variety of semi-structured and unstructured data. So if you think about Lego, and you think about if you have children, or even if you don't, some of us like Lego, even as adults, and you think about all the different colored Legos you've got, then they come in different sizes. They come in different shapes. They come with like 6 dots on the top, they come with 8 dots on the top. They come, the skinny ones, the fat ones, they come in Duplo. There are so many different types. How do you take that and organize it with all different sources? Because you've got like the princess, the Disney princess set, and you've got the Star Wars set, and you've got the Big Bang Theory set, you've got the general Lego set, you've got the creator set. How do you take that, sort it, organize it, and make it something useful that people can use to solve problems? We have 2 extra V's now. So in the past, when you spoke about big data, you only spoke about the 3 V's. Now we speak about 5 V's. So value. What is the social or economic value the data may create? Data is valuable. It is why the dark web exists. People get data about you. Criminals use it. Governments use it. Businesses use it. So some of the uses are very legitimate and others are nefarious. So it's about the value of that data, and then the veracity. Is it accurate? Is it complete? How's it stored? How's it analyzed? How's it collected?
Okay, so traditional data structures are predominantly the top 3 points there. So you're looking at things like string, so your character data, just your normal, places, names, ID numbers that are in text formats, that kind of stuff. As well as your normal numeric data types like a float, your integers, decimals, so all your normal numeric data that you can run calculations on, and then Boolean data, which is your true, false, yes or no type data. So those 3 points are your traditional data sets, which normally are structured. So if you think of it as an example, a payroll employees database. That's a structured database, and it'll contain most of these items. So things like your name, ID number would be a text field. The earnings would be a numeric field. And then you could have something like active yes or no, which is your Boolean type data. But now with the amount of different types of data that are collected, especially through things like websites, social media, email, unstructured data types are things like images, videos, audio files, web searches, GPS coordinates. So all that kind of stuff normally comes in an unstructured format. And that's what causes the challenges within storing, processing, and then reporting on big data, because the quantity is generally larger and the structures are unknown.
Like, when we speak about the images as an example, now we know that there are a large number of images of each of us floating around on the internet. And whether it's through social media and how we protected our social media or not protected, or because of our company websites as an example, because of other people's social media, not necessarily your own. They always say that every person has like a doppelganger out there. Now, how do we know that that person who might look pretty similar to you or me or someone else can't then open your phone, your smartphone, using their face? What security is there around that sort of data?
So when it comes to biometrics, the person's face would have to be pretty similar to yours. So if they had physical access to your phone, it may recognize the face as not yours. But I mean, I know my wife is a twin, and they look pretty similar. if they use each other's phones with facial recognition, it doesn't trigger.
I hope that you enjoyed that video. For more of our webinar videos, go to www.accountingacademy.co.za. Thank you and have a lovely day.